And we're back. This is part 2 of laying out stair stringers. We're going to, do 2, and we're making our treads 4 feet wide, so you really need a third one in the middle. But once you can lay out a stair tread for the side, if you just you can change your. I was going to say if you wanted to make a notch to here, and you've made the horizontal lines that we talked about in part 1 here. That's the level lines for your treads. You just slide the framing square back by the thickness of your riser board if you were wanting to cut that line, and then nail this on the front of a cut on the stringer. I think it's better to box it. The two sides, it makes the staircase stronger and neater, much neater. But it's stronger because the distance from the notch back to the edge of the lumber, 2x10, if you're using this line, 2x12 if it's that line, it's what is that, 40-some% stronger. Now, you're paying for the lumber, you may as well get something out of it. I knew there was going to be something added because we're going to part 2. Must be something long. We're going to do the math that's written down on a text file right on the same drawing here. Okay, if you know that the run is 9.8750, and you have to have 2 inches of toe kick, you add that. That's the width of your treads. And like we showed up here a minute ago, if we cut notches out of the back of our treads, this little straight piece here is going to butt up against the stringer, and this longer part of it's going to sit on the cutout on the stringer, and that gives us a lot more material at the depth of the notch right here. Well, we're going to do it to there. Well, sure, it's just here or over 2 inches to there. It's going to give us a deeper dimension here, because if you just drew a line down there across those, that's the only continuous part of the wood you got. So who wants to climb stairs that's basically built on a 2x4? And when you get into stairs, these stairs are, one, they're comfortable to climb. The codes give you that. You get the run and rise added up to 17.5, and that makes them easy to climb. The rise limitation just makes it for the geometry, ergonomics of humans. One other thing about this, let's just draw. When you're going up the stairs, you got this space here that your foot can sit on, and your toes can go up underneath the next tread. So you basically swing around and put your foot up on the next tread, but you got that much space to land a shoe on. It's almost 12 inches. If you're coming down, your heel has to come down in front of the tread you're standing on to something down here, and then your foot lies here. So you've got basically a 2-inch narrower tread coming down than you had going up. And when you're going up, basically your weight's on the ball of your foot, so you have some balance on the heel if you start to lean back, to keep you from tumbling to the bottom and having to start all over again. So you got a lot of leeway. But say you're coming down. Say your daughter, your wife, your significant other is coming down with 4-inch heels. The ball of the foot's out here someplace, but it can only come down from there to wherever, depends how much you want to scuff the shoes up, but come down here, and if the ball of the foot's there, it's over the top of something stiff here to take the weight, but your balance point is really close to the edge. So, you know, you don't want something where your daughter's going to take her shoes off to get down the stairs in your own house. So that's why these treads look wider than you normally see. You see a lot of treads that are only 8 inches here. You know, just get a piece of typing paper and put the heel at the back of the one edge of it and across the front, and see how much you got to step on. And that's why you use these codes. So we talked about the risers being different first and last and all the ones in between. And the end goal is to have the distance from where you step on one equal to where you step on the other. Okay, let's, yeah. Hopefully this is readable. Okay, in my first video, it was not readable. And I don't know what the difference is, but I'm glad it is. I'm going to have to make that a little smaller. It'll take away some of the readability, though. I'm not sure. Can you zoom a cell phone? Since that's what people tend to use these days. I think we're just going to have to move it back and forth. We're gonna pretend that you're reading the first line, and having, let's see, we can make it bigger. Okay, so you're reading the first line. We'll come across the end of the line. And then we'll go back, start the next line. The only thing that you can't change on stairs is the rise. Vertical distance from one tread nose to the next. Run is the horizontal setback from one stair tread to the other. To measure total rise, you must determine the top surface of the floor at the upper end of the stairs and the top of the floor from the bottom. Both the base floor and upper floor are called treads. With the same rise as all the intermediate treads. For instance, the bottom has a ceramic tile with a tile adhesive and an underlying concrete slab. The tile surface, top of the tile, would be the basically the bottom of the tread. The tread that you step on. That's confusing because there's a thickness to the tread, but what you're talking about is the top surface. If at the top there's a 5/8 inch thick, like a cut pile carpet, with a 1/4 inch carpet pad, and it's on 3/4 inch OSB, then the carpet top is the top tread. That's what you step on. These all have to be equal, bottom to top. This is measured the actual locations, not just straight down from the upper floor to whatever underneath of it, whatever lies below. Today we will calculate stairs with a rise of 106 3/4 inches, same as 106.750. There are 3 common sets of codes for building stairs. I'm going to use the commercial codes. For these stairs, run times rise must fall between 64 and 82. Run plus rise must equal 17.5. The residential code states that they must be 7 3/4 inches of rise. Obviously, this limits the level between floors to multiples of 7 3/4 of an inch. Therefore, we're going to use the industrial codes. I've never had anybody disqualify industrial codes because they're just so comfortable to climb. They walk up and down them, and they just can't understand why everybody else's aren't that way. These are stairs you can walk up really comfortable, or you can run up them 2 at a time. They're just nice They fit the math, and they work really well. Okay, the first step is divide the total rise by 7.5 to get the number of treads that you're going to use. And they'll be within 1 tread of what we need. And my mouse needs reset. For example, our total rise measured was 106.750 divided by 7.5. That equals 14.175. I didn't write that right. It's 14 treads with a 1.75 inch remainder. Well, we're just gonna say that that's what it is, because I'm reading this thing along too. Okay, the remainder after the 14 rises are subtracted is at 1.75 inches. Must be divided equally between the 14 rises. So 1.75, the surplus, divided by 14 equals 0.125, and that's the same thing as 1/8 of an inch. We add the 1/8 to the original 7.5 and get the actual rise of 7 5/8, or 7.5 plus 0.125 is 7 5/8, or 7.625. Runs easier. Take the 17.5 that's mandated, subtract by the actual rise, and you get a width of 9.875. That's 9 7/8. Now the next step is you mark the outside edges of a framing square. 7 5/8 on the short side and 9 7/8 on the long side. And gotta reset the mouse again. I'm working on a little tiny piece of something that hanging off the edge of the table. Okay, if you measure between the 2 points on the square, you're going to get 12.4762. But because of cumulative error, you really need to do this with math. A squared plus the run squared plus the rise squared, add them together and take the square root. Pythagorean theorem is what it would be. Square them and add them is easy. It's the square root that's hard. You need something that does square roots. I don't know about the cell phone, but I know calculator. If Android has calc in it, then you can do it. 7.4762. If you measured it on the square, you'll be seeing 12 and 31/32 plus a pencil width, and that's probably close enough. And that's a number you need to write down. A standard length toe kick, the amount that one tread extends back under the other, is 2 inches. Okay, that makes the width to cut the treads 9 7/8 plus 2, or 11 7/8. And we'll just arbitrarily make it 48 inches long treads. Also draw a line up the short rise side of the framing square where the riser face will go. I might be skipped a line in my reading. Oh, yeah, we done skipped a line. Time to mark a stringer. At the bottom end of the square, mark a line by the points marked on the framing square. Now, this is where you're going to saw the stringer off eventually, so it'll land on the floor and be sitting on the floor, not one point front or back and a gap under the wrist. This cut will eventually be the place to cut the bottom of the stringer. Sits on the top of the floor. That's provided your stairs have been built onto an existing floor that's already got hardwood or carpet or something on it. If you're putting it down to some kind of structural lumber or something, or OSB that's going to be covered up with other things, then your stringer will be that much longer. So leave yourself an inch up from the end to put that mark. But knowing you're going to have to actually draw on that thing the actual thing you're landing on to find out where it is along there. But you have to have a line to start. So we're going to just put a line that represents the top surface of something, and leave some lumber so that if it's not the top surface, you're going to add stuff to it, you got a place to add it. Okay. So you're drawing this, and you extend that line across, and this is a little light line. It's a construction line, basically. You're not going to cut this line. This light line is the top of a tread, so you must measure down the riser face line by the thickness of the stair tread. And if carpet or ceramic tile, you go down, you have to add that thickness to how much you go down. That's pretty much self-evident. Okay, what you just made now, after you've offset that run line, this new point is the cut line for the tread notch. Extend the tread line lightly to the back side of the stringer. Okay, because your framing square won't go across when you set it on the notches. Now you step off the rest of the notches with the framing square, but there's a better way. Carpenters just use the framing square, and if you do that, it's hard to get to measure the rise. Okay, so suppose I wanted to do it with a framing square. I have to know when I get done marking my notches out that I've got the right amount of rise. Because if your mark was off a 32nd of an inch, from on the framing square where you set it, or you made a real wide mark on the framing square, like this, if you didn't take masking tape and put a pencil line on it right where it's supposed to be, or you used chalk, we used, and when we were doing metal stairs, we used chalk. You really don't know how long that stringer has to be. Now, when I did a lot of metal stairs, I called them 5/4 stairs. And it does fit the codes if you do it this way. If you take your total rise height, divide by 4, and then multiply that by 5, you've made a 5/4 stairs. The run is 25% bigger than the rise. And if you do that, you can drop a plumb bob down from where you're landing the stairs, and however many how many rises you got, that's how many runs you got. And you can go out and mark at the landing the end of that diagonal, and then measure that with a measuring tape. It takes 2 guys, but you can measure the length of what the stringer has to be. And if you've calculated the diagonal, down to like I use 4 decimal places because the calculator gives me that. It doesn't hurt. But anyway, you take that number and you multiply it by 1, by 2, by 3, by 4, and out to, well, it'd be 1 less than the thing. It'd be 13 marks. And you mark those, you step them off along the front of the stringer, and then you've done that light horizontal line that's your cut, bottom of your cut. You do that up the back. When you connect it, you have the point underneath of the stair tread you're going to stick on it. And it all comes out, well, it just comes out perfect. The whole idea of reading this is to try to get you to build some beautiful stairs. Let's see anything else down here that's pertinent. Oh, okay. You've got this these horizontal, what's going to be the horizontals under the treads marked off. So if you set your framing square on that line, you can slide it back and forth, and at some point, the back line of the back edge of this framing square will meet up with the next tread cut mark, and that's where you draw your line to make the vertical cut. If you're if you're not using toe kick, go away. No, if you're not using toe kick, or if you want to include the riser board, you just slide it back and forth by those amounts to get your vertical line. You have to make a notch with a square corner, and the frame square makes a square corner. The rest of this text down here is telling you we're going to show you 3 different ways to basically mount the top of the stairs and what you do with the bottom. Let's go back to the drawing. Everybody's got to suffer through this drawing now. Wouldn't be fair if we didn't do that. We're going to say we lined up with what's it doing? Please. I want to stop. Go. No. No. There we go. And it's still moving. It had to get that one last lick in, didn't it? Just to make me totally lose my train of thought. Oh, okay. I don't care whether we cut this one that matches the back of the toe kick or we cut the one that's the tread, which is sort of my preferred way on wooden stairs. Or we marked it with the top, which we'll be doing on metal stairs. You got this long point sticking out. If somebody's walking up from the side and making a turn, you're just walking around going up the stairs, they're not coming straight at it from down the hall somewhere. They're walking around the end of the stairs. They trip over this chunk here because it's hanging out and you're looking at the stair tread, but this thing's down there. It's just a tripping hazard. So if you come ahead of this line by the thickness of whatever post, handrail post, if it's metal, or a 4x4 or whatever, you come out that thickness off of this nose line, and that's where you cut it. That gives you something to attach your post to, and no little point sticking out to trip over. I don't think we can say any more on that because that's just about as simple as I can make it. Now we're going to get to the hard part. We're going to mount the top. You got several things that you might have at the top. All 3 of them are drawn here. This bottom line represents a, let's see which size it is. 9.5, that's a 2x10. Okay, so if we had floor joists running out here, you're coming into, like the stairs are looking in between the floor joists. You can add another joist, or you can put your stairs where there is a joist on one side. And if this is the back of your stringer, and you've got this this joist here, you can screw, bolt, nail into that. Just lap them over. If you're putting intermediate ones, stringers, then the floor joist is 16.5 inches on center. You can get 2 more stuck. The last one could be hanging out in space, or you could put a cross blocking in here between the stringers, and then a little short one out, and attach that. Same lap over kind of thing. Because see, you haven't got these. Not where you're putting your stairs, you haven't anyway. Now, the second thing is, say you where you landed, you had these. Like all the frameless where you're looking into the ends of it. The stringer's running crosswise of the stairs. So you have a band joist here. Obviously, you can stick it to that. So you would make your cut down here and then back there. You'd be cutting this 90-degree angle out of the stringer because it's going to push up against this. It's going to sit under that. That gives you the top. So what you basically do is when you have your treads drawn on here, you draw this other one in just like it was there with the stuff that's on it, because it's going to be a different thickness than a tread just about every time, unless you planked your whole second floor with framing lumber. Not common. Um, okay, so you can lap it, you can butt it. Say you had uh, these floor joists. I don't know if you can see that purple line or not. What color have we got there? Anyway, if you take a piece of framing lumber, you can put it between those floor joists, and that's if you didn't want to add a full length joist across the room. I don't know, maybe have heating ducts or something that you just can't add a piece of lumber in there, and you don't like the idea of a little short piece here stuck between things to land your stairs on, because it would only be attached here and sitting on something down below over here. It could be a concrete block wall, or it could be house framing, who knows. Anyway, if you don't like that, you could put your blocking in. You'd put one in, and nail in from the side of the floor joist into the end grain. Not a very good joint, but it gives you a great thing to land the stair treads on. And this angle is the same angle as marked on your framing square. Okay, you already know what angle to stick it on there. You have to figure out how far back it has to go by measuring the width of the stringer. With that phantom line you do to step them off, that's this line here, obviously. So it's going to butt against that. And then you can draw this piece in. Basically, you want to draw what it's landing on the side of the stringer to figure out where to cut it. Just draw your little to scale thing on there, whatever the building has got. And you stiffen it up with the second one underneath of it. And then I would take a piece of 2x4 and put it under that one. Or you could put it under this other one and skip this piece, but I'd use 2. And you'd put that under here and bolt or screw that into the side of the joist. So that thing being in shear and with little construction adhesive, it would carry 10 times the weight of the stairs. So that's the third way to mount the top. Anything else to say about stairs? Okay, this is our 48-inch tread. It's 48 from back to that. Because we want to have a place to register the riser board back here, and you don't want any daylight showing at your toe kick, so you cut the notch, the toe kick depth, which is 2 inches. And then the part in here, because what you're doing is making this clear the stringer. This outside here is sitting on the stringer, so it's flush with it. This is the thickness of the stringer. So the framing lumber, when this video was made, was 1.5 inches. No telling what it is time it gets published. Tomorrow it might be 1 3/8. They're going to get it down to less than 1 inch pretty soon. Anyway, you cut those notches out there. It makes the distance from the notch. Basically, we'd be moving the notch over to here, to this, what you can't quite see, purple line, and then from there to the back edge is how strong the stairs are. When you look at concrete stairs, in this channel, you'll see some concrete stairs we built. We solved the spiral stairs that you can't walk up or down on except the outside edge. We can actually climb up the full width of the stairs, and we can come down. We've still got plenty of landing on each tread. I'd say 2/3 or 3/4 of the way across the tread, you can come down them without looking at them. You can climb they're helical stairs. It goes around in a circle. You can climb those without looking at them. You can climb them without a handrail. I mean, the regular spiral stairs or circular stairs, whatever you want to call them, they're actually different. One's a helix and the other's a circle. You can't use most of the stair tread because it goes to a point. Basically, you offset the to the tangent of your circle and you make the circle bigger. If we'd have made 5-foot wide stair treads, then we wouldn't have made any difference. We were going smaller, like 3.5 feet. So we just made the center of the helix like 2 feet and did this, the stairs around it. The original idea was we're going to have a brass fire pole down there. We just slide down the pole and climb the stairs, but we weren't going to work our way down one step at a time. We were going to just put an arm around it and slide down it. But then now we got 80 years old time we got around to building the house, so we left out the fire pole. Yeah, that's something that would just make old people crazy with kids using it up and down to be a play toy. It's just not going to happen. Anyway, that's part 2 of how to build a stairs. We actually used this same formula on the construction stairs